Good day, students. Lesson 2, Video D. We're looking at graphing. Previous lessons, we looked at graphing categorical variables. This lesson and the next, we'll look at graphing quantitative variables. The graphs are different, so we got to make sure we get the right graph for the right kind of variable. All right, graphing quantitative variables. When graphing one of these, the first graph we should always make is a histogram. You can see the picture. This is a different example that's in the notes. The one in the notes will come up, in the next slide. But here's what a histogram looks like. Don't confuse this with a bar plot or a bar graph. They're quite different. I'll explain a few of those differences as soon as I get this down. The word's histogram. I guess the main difference we should think about, we're graphing a quantitative variable, so this is a number line here. Okay, the spaces between numbers matter. If I have no data between a certain spot on the number line, then we'll see a blank space here. A bar plot doesn't have that feature because on a bar plot, this will be a categorical variable. Okay, so we're looking at numerical variables, quantitative. This is the primary, most important graph you can make. The other two that we'll look at in this course, dot plots, which are pretty darn simple, and they're great on StatCrunch. When we use the software in class, StatCrunch is great because dot plots are very interactive, and you can go find data values very easily. But we'll save that for class. Box plots come later in a few lessons, so for now, let's just concentrate on histograms. There are a lot of features we're going to need to note on a graph such as this. But I'll flip the slide so we can look at the same one that you've got in your notes. All right, so here's the example in the notes. Continuing with that general social survey data set. Remember that was the data set with thousands of people and I think 60 variables. Here's a variable that we'll look at its number of children. Okay, here's the histogram. What I would like for you to do is try to imagine, can you sort of draw a smooth curve to describe the general pattern, not necessarily looking at the exact heights of these bars? And, if we did that, we might get something that looks like this. And let's talk about some of the important features. We have a big pile up of data here at 0. These are the people with no children. If I go to the second rectangle, these are the people with one child, okay? And if I move to 2, you can see there's more people have 2 children than 1. And 3 and 1 are about the same. So we're getting this bimodal pattern where there seems to be 2 distinct peaks, okay? Another thing we can look at. Most of the data is piling up on the low numbers. The taller these bars are, the more data values that we have there. There are a ton of people in this data set with no kids, more than 500. There are a ton of people with 1 kid, 2 kids, 3 kids. And then, from real life, it starts to tail off. The rectangles aren't high. This means there's not a lot of data. All the data is piling up on that left side, okay? So a couple words we'll use to describe this, and we're not going to define them for a slide or two, but let me just put them on the board. I would call this bimodal. The modes are the major peaks. I've got 2 major peaks. Bi is the prefix for 2, like bicycle, so I would definitely say bimodal. And not to confuse you students, but with all the data piling up on the left, and that tail off to the right, this would be what's called skewed right. So this is bimodal and skewed to the right. Write it down for now. In a slide or two, we'll define these words more carefully. When I'm looking at a histogram, I might want to try to pick the center. What value accurately describes the number of children a typical person might have, or the middle value? If I look to the blue area, I want to try to chop the blue area into 2 equal pieces. What I don't want to do is put my left hand at 0 and my right hand up at 8 and say, well, 4 is in the middle of that, so that must be the middle of this distribution. Clearly, that doesn't seem to describe what's happening in terms of the center value. Okay, let me take a peek at my notes because I did this real careful at home. That's what I thought. Somewhere in here, and I'm just going to slam it right on 2 there. This is about 50% or half of the data, half of the people. Half of the people have 2 kids or fewer, 2 children or fewer. About half of the data, half of the people in the data set have about 2 children or more. So if you wanted to pick a number that describes the center, that would be a good number. I'm trying to put the line to split the blue of the histogram up into 2 equal pieces. Okay, so a value of 2, I'll just say kids because that's easier to write. A value of 2 kids seems to describe the center. Other things we can look at quickly, and then we'll move on. How much variation is there in the data values, right? From this histogram, all I can really say is that I know for sure that a minimum is 0 children. I know for sure the maximum is 8 children, so I could say what? That values range from 0 to 8. That seems to be an important fact. Values range from about 0 to 8 kids. So we're talking about shape, we're talking about the center, we're talking about the spread or variation. And the last thing we'll need to mention is there anything that's catching your eye? Is there anything unusual about this picture? I really don't think it's unusual to have 2 peaks, one at 0 and one at 2. I mean, just think about all the families that you know and how many children are in the families or people that you know. Do I have any unusually high values? These are all relatively connected. In a few lessons, we'll come up with rules. Are these outliers? Are these unusually high? Would it be unusual to run into somebody with 8 children? It seems unusual. Based on this picture, it's sort of a judgment call. So I don't know how we summarize that. This is not an exact science. I could say something like, there's nothing too unusual. Maybe there's a few people with an extraordinarily large number of children, right? These folks with 8 kids, 7 kids. So maybe a few people with, I'll just put it, right? Extraordinarily large or high number of kids. That's sort of amazing. Like, we've just got this one picture and a 1-sentence description, and I've written like a paragraph of information here. But students, this is going to be the expectation. We'll be analyzing data, well, I was going to say often, but the whole course. We need to think of these things, okay? Shape, center, spread, unusual features. So, the rest of the lesson, and I think the next video, that's the point. Let's practice and get this down. All right. Now, let me get this cleaned up here for us. We did a pretty thorough job, so there shouldn't be too many surprises going forward here. From this graph, we must take note of something. Well, we said it. We must take note of the shape. That means skewed or symmetric, how many peaks, we'll get to it. We can estimate the value of the center, right? So shape, center. We can estimate the spread. at this point, just by sort of looking at the range of possible values. And finally, we can list any unusual features or outlying values. Okay, 4 things. Get these down. Students often give us 2, and then we'll take 2 points off. Easy points. It's the beginning of the semester. 4 things, write them down. Let's talk shape. If the histogram is roughly, and I'll circle roughly, when you collect real data, you're never going to get a perfectly symmetric picture, but if it's roughly mirror image, if you folded the paper in half, and it looks the same on both sides, those data are called symmetric. If the long tail of the distribution is to the right, the data are skewed right. And this is tricky. It seems backwards almost, but it's correct. If the long tail is to the right, the data are skewed right. I put it in red here on the slides. This means most of the data are piled up on the left. Okay, think back to the first picture with number of kids. It's skewed right. The tail's to the right. And the opposite. If the long tail's to the left, the data are skewed left. Skewed left means most of the data are piled up on the right. Okay. Sort of is what it is, and to this day, almost seems backwards to me, but it's right. So let me reference my notes here just to make sure I'm on track. I believe we're going to start talking about some shapes here. And yes, bottom of the page there's a few graphs. Let's see, here's a histogram. When I bowled in a men's league, these are the team bowling scores. So it's 5 guys. These are the scores added up. You can see the center. If you had to guess one value, probably 1,000. And if I'm talking about shape, this is clearly what? Clearly pretty darn symmetric, right? This is pretty symmetric. It's not perfect. You know, there might be a little bit of a longer tail off to the left here, but we're not going to worry too much about that. All right, so bowling score is pretty darn symmetric. And this isn't hard, right? Here's the second one. Going back to that general social survey, number of people living in a household. Clearly skewed to the right. Most of the data is piled up on the left. If we tried to smooth it out to represent with a smooth curve what's happening, I would get something like this. This is clearly skewed right. All right, and you can guess the last one because it's the one we didn't do, so of course it's skewed left. Back in 2010, I've got hurricane pressure readings, probably in millibars. Not a lot of data here, but if you had to make a judgment call, I suppose you could say skewed to the left. There does seem to be more data piling up towards the high pressures. So this one is definitely skewed what? Skewed left. I just thought of a good question, because sometimes I think students have trouble reading histograms for what they are. How many hurricanes do I have in this data set? I'll even write it down up here. How many hurricanes altogether in this graph? And if you say 4, that's the wrong answer. A lot of students incorrectly read this and say, well, if I go up here to the top, frequency says 4, must be 4 hurricanes. And no, there's 4 hurricanes here, right? In this, the largest values, there's 4 there. And plus these, it's 4 more. 4 more there, and it's got to be what? 1 more, 2 and a 2, and a 1. And boy, if I could add that up, 4, 4, 4, and 4 is about 16, 17, 18 hurricanes. 12, 14, 16, 17, 18, yes. Okay, with a relatively few number, we can get the exact answer without too much trouble. If there was tons of data, I couldn't be so accurate, but keep this in mind, students. This is not how many data values there are when we're looking at a histogram. All right, bit of a pet peeve of mine, I guess. Slide over to the next page, wrap up this lesson here. One more feature talking about shape. So we know skewed versus symmetric. And if we're talking skewed, we know which way, left or right. So with shape, the second thing we need to mention is the number of what's called a mode. All right, number of modes. That's the official word. This is terminology for the number of major peaks. Right? If a variable has one major peak, the general pattern, students, we're not looking for, you know, some oddball where there might be one extra data value, so there's this little tiny peak at one end. Major peaks. It would be called unimodal. Right, the prefix is for one, like unicycle, so unimodal, one major peak. And without even me flipping the slide, you could probably guess the next two. Two major peaks would be what? Bimodal. So two major peaks, we would say bimodal. Could even be multimodal. The thing is, with getting into like, is there 4, 5, 6 major peaks? Once you start having that many major peaks, are they really major when you think about it? Okay, so we do have multimodal, but just be a little bit careful with that. If the bars in histogram are all roughly the same heights, there's no mode and the data are called uniform. So it'd be uniformly distributed across the number line. Okay. I don't know if there's an example. There probably is if I flip the slide, but I'll draw you a real quick picture of uniform just so you have an idea to put to the word. If I collected some data and made a histogram and say that happens, right? It's not skewed to the left or skewed right. All of the data in that histogram is roughly the same frequency, whether you're in the low values, middle, or upper. It's not perfectly even, but roughly even, this would be uniform. Okay? And for that matter, symmetric by default, because I suppose you can fold that in half in the middle and it looks roughly the same on both sides. Okay. At the bottom, I'm seeing a little note here. Return to the previous 2 pages and note the shape. Look at that skewness and modality. For all intents and purposes, we've done this, but let's get it back up again. For a number of children, this is skewed right, this is bimodal. We know, I'm not even going to write it down, because we know it, right? Bimodal and skewed right. For the bowling scores, this is what? Symmetric and unimodal. One major peak. What's this one? Number of people in households, right? Skewed to the right. And unimodal. And lastly, hurricanes was skewed to the left. And is it bimodal or is it unimodal? Tough to tell. It's a hard call. I would probably accept either answer as an instructor. If you're seeing this and you say unimodal, no problem. If you are seeing something more like that and you say bimodal, I'm with you. If, it's getting a little messy here, but if you're going to tell me 1, 2, 3 major peaks, multimodal, I'm going to say no way. This is, how many hurricanes are, this is one hurricane, right? We can't call that a major peak, it's one hurricane. So I would take unimodal or bimodal on that, but not multimodal. All right. So, is that it, or do we keep going? I guess we keep going. Bottom of the page here. Example At times, we might tell you, students, think about a variable and sort of think what the data values might look like. Think about what the shape would look like for the following variables. And what I'll try to do is draw a smooth curve to represent it. I'll make sure I label the axis and I'll estimate the center. Okay, so we'll do it twice. First example, let's try to think about home values in Cecil County. All right, so home values. There are some homes that might be worth only 15, 20, 25,000. In certain parts, there are tons of homes worth 100,000, 200,000, 300,000. But as I get bigger, right, 300,000, 400,000, there's fewer and fewer homes. So let's draw a picture of this. Here's home value. I've got a hard left here, right? The lowest amount a home can be worth in Cecil County could be 0. Maybe here's 100,000. I'll write that as 100K. Maybe here's 200,000. Maybe here is 300,000. 400, 500, 600, 700, and so on, right? Do I have some homes here? These are the cheaper houses in the county. I sure do. There's probably more homes here, between 100 and 2. More or fewer, about the same, or maybe less. I don't know precisely where this is going to peak. But if I tried to draw a smooth curve, I might get something like this. I don't know if the camera's going to follow me, but this is 3, 4, 5, 6, 7, 8, 9, 10 would be a million. Here's 1 million. Do I have any homes in Cecil County worth $1 million? Of course. Could I keep going here into the 1.5 millions? Sure. Could I go all the way over here to this yellow and get up to 3 million? Well, sure. Are there a lot of homes way out here to the right? Not at all, right? Most of the homes are all piled up way over here to the left. So clearly skewed right. The long tails to the right. This is clearly skewed right. It's got to be unimodal. I mean, I've never really collected the data, but I cannot imagine there would be 2 major peaks. It's somewhere here in this typical middle-class home value, right? So I'd bet money unimodal. The problem asked one last thing. It said, can you estimate the center? The center would be, where's the halfway point in terms of area under this curve? Halfway point? Let's just make a nice easy number. Let's call it 200,000. Could be up here a little bit, could be down here a little bit, but best guess, I bet half of the homes, 50% of all homes in Cecil County are probably 200 grand below, half are above. Okay, they're more piled up here. There's more data sort of in here than from the 200 and all the way out to those couple that are in the millions. Okay, so value center 200,000. If I asked you to do this, students, you'd have some leeway using common sense and context clues. You know, you can sneak up here a little bit with your guess. You can sneak down here with your guess. But I think if you're saying 100,000, we might have to question that. I think that's too low, right? And if you're saying 300,000, we'd have to question that. I think that's too high. There's sort of a sweet spot in here. All right. I think there's one more, then we're done with this video lesson. Last one, numerical grades in a Math 127 course. So the variables, final grades, last semester in statistics. I don't think the video is going to pick this up all that well, so I'll read it to you. I'm not sure if it's in the notes. I don't think that it is. But here are some final exam grades. I had an 86, a 91, an 83, 68, 95, 86, 57, 75, 77, 45, etc., etc. Okay? Typically, course grades, let's draw the picture. For all intents and purposes, the highest you can get is 100. Okay, forget about instructor errors and some sort of extra credit or something. Doesn't happen all that often. Here's 90. Here's 80. Here's 70, 60, 50, all the way down the line. All right. Believe it or not, most students are not down here in the 0s, 10s, 20s, and 30s. Most students do quite well in the course. I'll draw this one as a histogram first, then I'll put the smooth curve. But what is this? This is a final exam. Final exam is probably going to look like this. Here's my biggest peak. Between 70 and 80, that's probably the tallest bar in a histogram. There are quite a few 80s to 90s. In fact, I'm just going to do that. Almost as many, just a few less. And 90s to 100s, sort of tough to get an A on a final exam, right? But there's still plenty of people. Maybe looks like, oh, about here maybe. And let's look at the grades as we get down to the bad half here. So 60s to 70s might look like that. And as I go down in the 10 points, there's fewer and fewer students down here. Okay. They still exist though, right? There might be something like this. Oh, here's a student that just really didn't know much. So, and here's one, didn't come, since spring break till the end, but decided to show up for the final. And so there he is, right? There's down there. Got an 18. Make that straighter there. What's the shape? Most likely this is unimodal. And the skew is to the left. This is unimodal and skewed left. If you drew the smooth curve, you're getting this happening now. Most of the data is down here. Most of it's between 70 and 100, maybe 60 to 90, right? This is a big bulk of the students are here. All right, so we do have to pick the center. I can see my actual median was 77. I'm not sure the video can pick that up. But if I put a line here at 77, this is half of the students, 77 and above. Here's the other half of the students, 77 and below. That's a perfectly good value to describe the center of that distribution. All right, so we learned all about shape. Next video, we'll learn more about what? Talking about outliers, talking about the center, talking about spread. All right, we'll see you in class. Thanks for watching.